Good morning everyone. I'm taking this topic segmentary. In this video we will see what is segmentary, why we are using segmentary, importance of segmentary, how to create a segmentary, structure of the segmentary, then advantages, disadvantages, applications, real world examples, and what are the operations in segmentary. Those topics we will see after. First we will see what is segmentary. Segmentary is a special tree used in DSA to solve the problems related to ranges. It's a binary tree used for storing intervals or segments. It's commonly used for solving problems involving a sum, minimum or maximum, greatest common divisor, etc. Efficient for answering range queries or updating elements in a logarithmic time. Imagine you have a list of numbers. You you have to find the sum of numbers between two positions or updating a new number quickly. In this scenario, segmentary helps you to do this efficiently. Importance of segmentaries. Efficient range queries and updates allows operation like sum, minimum, maximum over intervals in logarithmic time. Dynamic data handling. Dynamic data handling ideal for application needing frequent updates and queries over ranges. Memory efficiency. Memory efficiency manage large data with minimal storage by dividing it into segments. Application in competitive programming and real-world uses. Used in computational geometry, database, and high-performance range operation. Basic structure of a segmentary. We have root node, internal nodes, and leaf nodes. First, we will see root node, which is the topmost node represent the entire list. It's called root node. In this given example, 36 is a topmost element, so this is a root node. Then internal nodes. These nodes represent segment of the list. In the given example, 9, 27, 4, 5, 16, 11. These are the internal nodes. And then leaf nodes. These are the individual elements of the list and it don't have any child node. In this given example 1, 3, 5, 7, 9, 11. These nodes don't have any child node. So this is called leaf node. Then how to build a segmentary. First we will choose an array. For example, let's use 2, 4, 1, 3 and then 5. We are taking the example. Then create the leaf node. Each leaf node represents a single element of the array. In this example, we have 5 leaf nodes. 2, 4, 1, 3 and then 5. Then build internal nodes. Combine pairs of leaf node to create the parent node. Each parent node stores what are the operation you take. The result will be stored in the parent node. Then repeat the process until the root node is created. In this example, we taking the operation is sum. Sum of 2 and 4 we got 6. Then sum of 1, 3 we got 4. Then sum of 6 and 4 we got 10. Then finally sum of 10 and 5 we got 15. Operations on segmentaries. We have two operations under segmentary. One is point update, then another one is range query. What is point update? Modify single element, update affected segmentaries. The time complexity will be big O of log n. Then range query. A query operation in a segmentary allows you to retrieve the informations. We will see example for range sum query. Uh, for example, we're taking the array 1, 3, 5, 7, 9, 11. Find the sum of elements between indices 1 and 4. First, what are the leaf nodes? 1, 3, 5, 7, 9 and then 11. These are the leaf nodes. In this example, we're taking the operation sum. So, sum of 1 and 3 we got 4. Then sum of 7 and 9 we got 16. Then sum of 4 and 5 we got 9. Sum of 16 and 11 we got 27. Finally, sum of 9 and 27 we got 36. This which is the topmost element of the array. Let's see another example. Uh, let's use our previously built segment tree for the array 2, 4, 1, 3, 5 to find the sum of elements from index 1 to 3. The range will be 4, 1 and then 3. In this example, we will find sum of the elements. Sum of 2 and 4 we got 6, and sum of 1 and 3 we got 4. Then sum of 6 and 4 we got 10, and then finally sum of 10 and 5 we got 15. This is the example for ransom query. The another operation is update. For example, we are taking the previous array 2, 4, 1, 3, 5. We are going to update the element 6 at the position of 2 in that array. Then we got 20. The previous example, we got 15. We are updating the element 6 at the position 2, so we got the different answer. Lazy propagation. The problem is frequent updates over a range can be inefficient. The solution will be lazy propagation allows deferred updates. Each node keeps a lazy value that is propagated only when necessary. Reduce update time complexity for range of time complexity. Time complexity of construction is big O of n. Time complexity of point update is big O of log n. Then time complexity of range query also big O of log n. Time complexity of range update with lazy propagation also big O of log n. Applications of segmentation. We use segment trees in various ways like range sum queries, dynamic order statics, inversion count, competitive programming, data compression, finding greatest common divisor, then LCM, range minimum or maximum queries, range sum queries. Like that, we, uh, we use segment trees in various applications. Advantages of segment tree. Efficient querying and updating for dynamic arrays, easy to implement for most range-based problems, can be extended to more complex operations like minimum, maximum, greatest common divisor, LCM like that. Limitations of segment tree. Segment tree has some disadvantages like it requires 2n memory space, complex to implement compared to binary index tree, higher constant factor for simple use case. Real world analysis of segment tree. For example, we take bookshelf section. Think of a long bookshelf with many books. Each shelf can be divided into smaller sections. If you want to know the total number of pages in a section, you need to count the each book's page individually, but it's take a lot of time. Instead of if you have already the total pages counted for each section, you can quickly find the total of any group in the book section. Another real world example is warehouse inventory. Imagine a warehouse with many products. If the manager wants to know how many items are in a specific range of section, having a record for each section allows the manager to quickly add up the count from the relevant section instead of counting each item individually. Conclusion. We have seen what is segment tree, how to create a segment tree, why we are using segment trees, and then a structure of the segment trees, what are the operation under segment trees, advantages, disadvantages, time complexity, lazy propagation, real world examples and applications. Those topics we have seen. Thank you for your attention.